Hello, my friends. Today we will resolve this problem. It says the structure shown in the figure is subjected to a horizontal force of F equal to 300 newtons. This is a Cartesian vector. Determine the magnitude of the components of this force that are parallel and perpendicular to the element AB. We have the element AB. It's a type of frame, and we have an horizontal force. It's completely parallel to my y-axis. Just recalling some concepts about dot product. Here we have the example for how is used the dot product to find the magnitudes of the components of a vector parallel and perpendicular to the line. In this case, this is my parallel line, and the perpendicular should be the other one, 90 degrees here. For a force component parallel to line, in this case is AB. Here is B. So let's use exactly the same formulation that we have from the dot product. These are my equations, and we can adapt these equations according with my current system. So let's go back to the scheme. For the scheme, let's think that we have another axis. Actually, we have a different axis. I will use the line from here. I'm just drawing this line that shows the direction of my element AB. On the other hand, we have a perpendicular line to my element AB. Using these lines as a reference, it's possible to show a parallelogram to find what are the components onto my AB line and the perpendicular one. On the other words, it means that we can get our components on the corresponding yellow lines. I will call one that goes here as FAB, and the other I can call it as a F. I will say P because it's perpendicular. Okay, so remember that actually, thanks this formulation, my force AB is a vector plus my force P as a vector too. It's equal to the magnitude of the force. In this case, we know that it is 300 newtons. J. Fp is a perpendicular. It's equal to F minus FAB. So my first step is the position vector. My first step is to get the position vector. What position vector? The one that goes from A to B, because we need to break in components about these yellow lines. In order to get what is the position vector AB, we need to use the coordinates. So my coordinates here are 0, 0, 0. And for B, my coordinates are on X is 2 meters, 6 meters, and 3 meters. Everyone is positive. We know that if my position vector goes from A to B, it means B minus A. So B minus A is 2 minus 0, 6 minus 0, and 3 minus 0. On that way, my position vector AB it's equal to 2 minus 0 is 2i. 6 minus 0 is plus 6j, plus 3 minus 0 is 3k, and the corresponding units. The magnitude of my position vector is equal to the square root of 2 squared, summation of these numbers, 6 squared plus 3 squared. Then my magnitude is equal to 7 meters. Okay, using the definition of a unit vector, we know that the unit vector in this case for AB, unit vector, it's equal to the position vector AB over the magnitude of this vector. So my unit vector AB, it's equal to 2 over 7 I plus x over 7 j plus 3 over 7 k. So it's equal to 0.286 plus 0.857 j plus 0.429 a. And remember that the unit vector is unitless. Okay, following the formulation of the problem, we have here the dot product. We want to get the component, the one that is parallel or collinear to my yellow line, AB. So this unit vector actually is the unit vector U, AB, and this F is F, AB. Remember, both of them are vectors. Okay, let's continue. Our original formulation is here at the top, and it says that we can find the force that is acting on the same line of action of my yellow line, in this case is AB, from the component AB. So this FB for us, for this problem, is the FAB. F is the force that we have as a Cartesian vector of 300 J newtons, and my unit vector AB, it's equal to the vector that I have here. Yes? Well, in addition, remember that we have this formulation to calculate the dot product as well. I will say the left side of my equation. Actually, the same that we have here. This two vectors and the dot. Two vectors and the dot. So we need to take care about my vectors, because actually my force F, it's equal to 0 I plus 300 J plus 0 K newtons. So if we apply this formulation, I can do it for F dot unit vector UAB. It's equal to the product of the corresponding components. So 0 times 0.286 plus 300 times 0.857 plus 0 times 0.429. So this is 0, this is 0, and my product that actually it's equal to my f AB, it's equal to this element. F AB is equal to 257.1 newtons. This is just the first part of my results. It's important to clarify that actually this FAB is not a vector, it's a magnitude. That's why we have here just a single number, a magnitude. So if we have the magnitude and we need this force, the force AB as a Cartesian vector, what is needed? Obviously, we are sharing my vector FAB is sharing the same line that my element AB. So they both are sharing the same unit vector. So it means that I can use the unit vector that I have here, multiplying this unit vector times my FAB, the result that I already have here. This is a magnitude, remember. This is just a magnitude. Let's multiply my force AB times my unit vector. In that way, I will have the component of my vector FAB onto the line AB. So my magnitude of 257.1 newtons times my unit vector and finally the third component of my unit vector. This is equal to my FAB as a Cartesian vector. So my Cartesian vector AB is equal to 73.53 plus 210.33 J plus 10.3 K newtons. Okay, let's go back to the theory and let's check what happened with the theory. What the theory says about the dot product. Well, remember that we have another way to calculate the other vector, the perpendicular one. If I know the hypotenuse and one cathete, on the other hand, I can subtract from the hypotenuse the other vector. Graphically, it is represented by an arrow that goes from tip to other tip from my vectors. If I'm subtracting f minus fb, my arrow goes from fb to f. So this is the formulation that I have here. My f perpendicular to the line is this one. It's equal to my f minus fb. On the other words, my f here is the one that I call p, that is here. It's equal to my f that we already know. This is the one that is completely horizontal. It's zeta minus my f ab. Those are vectors. Give me a chance to reorganize a little bit this page. Okay, And let's continue now. So let's use the same formulation that we already know from here. But what happened is we will substitute instead the formulation, obviously. So my FP as a Cartesian vector is equal to my first vector, that is F. F is 0i plus 300j plus 0k. And this is minus my vector that I already have calculated here. And remember again, really important units. FP it's equal to 0 minus 73, 300 minus 210, 33 is positive 79.67j. Finally, minus 10.3k newtons. But actually, the problem is not asking for the Cartesian vectors. It's asking for the magnitude of the components. So the next step here is to calculate using Pythagoras, and it's going to be complete my problem. Let's do it. So the magnitude of Fp it's equal to the square root of the summation of every single element squared. So the magnitude of Fp is equal to 154.6, and remember newtons. So now my problem is completely resolved.